Hello everyone, my name is Steven Gallardo, and this is my presentation of the facial recognition and future and other issues surrounding the technology. So, uh, facial recognition is defined as a form of technology that uses your face to identify or confirm an individual's identity. Many people were first introduced to the concept in 2017 when Apple originally launched the iPhone X, and this release saw iPhone shift away from using fingerprint recognition and instead utilizing a suite of advanced technologies to deliver a seamless user experience, popularizing the idea of Face ID. While this is still the most popular form of facial recognition, it certainly isn't the first. So when did facial recognition actually start? So as we see here, I have a timeline laid out which shows the beginning of facial recognition, or also known as the first automated system back in the 1960s. So back in 1960s, it actually started by American mathematician Woodrow Wilson, Woody Bledsoe, who developed a system for classifying photos of faces through a RAND tablet. For context, a RAND tablet is a graphical computer input device that claimed to be one of the first digital graphic devices marketed as being affordable and low cost. Using the device, Bledsoe could manually record the coordinates of locations of facial features such as a person's mouth, eyes, nose, and even hairline to identify individuals with the closest numerical resemblance based on the plotted information. Several others also soon added to this development, such as Helen Chan Wolf and Charles Bison, who helped develop the Pittsburgh face recognition system using Bledsoe's work. The next greatest development came in 1987, but officially came out in 1991, just at the start of the rise of feature focused engineering. This was when Surovich and Kirby introduced the idea of the eigenfaces algorithm. This approach showed that analyzing features across a set of images could produce a compact, low-dimensional representation of facial data, enabling a form of facial recognition that emphasizes a person's most immediate and distinguishing features. But most importantly, it also established that less than 100 values were actually needed to accurately code a normalized image of a face. This method would eventually become the basis of many deep learning algorithms, paving the way for modern facial recognition solutions. In 1997, Bellhumer, Hispana, and Craigman developed the Fisher face algorithm using linear discriminant analysis, or otherwise known as LDA. This method improved recognition by focusing on features that best distinguished individuals, improving the robustness under varying illumination, and enhancing face recognition performance. This also spawned the debate between LDA and PCA, with PCA representing principal component analysis, a separate technique that involves dimensionality reduction to extract key features from images. The key difference between the two is that PCA maximizes variance without considering class labels and is primarily used for feature extraction, while LDA maximizes class separability by focusing on the distance between the classes, making it much more suitable for classification tasks. These developments also carried on into the 21st century, where we got one of the most groundbreaking technology developments of the time with the Viola-Jones algorithm. This algorithm was created by Paul and Michael Jones and enabled us to perform real-time face detection within consumer devices. It revolutionized how facial recognition was at the time, as it could detect 15 frames per second on early 2000s hardware and utilized simple features and fast computation, which made it ideal for embedded systems and cameras. This introduction was also really massive in the sense that it introduced the thought of using a handheld camera, allowing us to then develop 3D facial recognition in the following years in just 2006, using the Viola-Jane algorithm as its main incentive. This wasn't just all that the first era of facial recognition gave us. During this time, facial recognition was starting to become really well known and was even starting to become adopted at certain airports, especially following the 9/11 attacks for surveillance purposes. Government agencies sought out technologies to enhance national security, and facial recognition was amongst one of the most promising tools of all, rising quickly during this time. While now being implemented on a much larger scale, new issues would arise from all the new forms of its use. The most common struggle the system faced was with lighting, image quality, and diverse facial expressions. Now, for the next era of facial recognition, we have the deep learning revolution, which started in the 2010s. Its first notable development was in 2014 with Facebook's deep face technology, which helped achieve near human accuracy using deep neural networks. Specifically, it was trained on 4 million images and uses 9-layer neural network with over 120 million parameters. But what does that mean? So what this means essentially is that the system would run 120 tiny knobs that help adjust the system while learning, helping it become more proficient the more it is used. It's almost like an earlier version of AI. It would also go through 9 stacks of filters, each helping the computer understand an image step by step. The next development was in 2015 with Google's FaceNet, which introduced embedding-based recognition, helping to improve scalability and precision more than it has ever before. These quickly evolving methods would be the key factors for Apple's Face ID on iPhone X, which launched during this era in 2017 and popularized facial biometrics for the consumer authentication. This, up until now, has been the biggest boom for facial recognition and easily made it a mainstream concept. This is usually the era where everyone began understanding what Face ID and facial recognition actually was. What followed was the widespread adoption in law enforcement, retail, and smart cities in just the following years, and what would come out of that was also the era of controversies. One of the biggest controversies in this era was Clearview AI's controversy, which faced global controversy for scraping billions of images from the internet without consent to build a facial recognition database, leading to many lawsuits, regulatory fines, and criminal complaints across multiple countries. That went on for about a year, and then once news broke, many cities began banning the use of facial recognition until further regulation was put in place due to privacy concerns. So where does this bring us now? This now brings us to the 2020s. And while facial recognition continues to be refined every year, it also caused a lot of issues and concerns to arise as well. So these are kind of the current issues and biggest issues up to date. These are essentially some of the most vocalized issues revolving around privacy violations and mass over surveillance. People are now growing concerned that many of these systems that law enforcement use are collecting and storing facial data without explicit consent. Furthermore, it has created panic within some who think this is leading us to becoming a surveillance state due to multiple cities admitting they use real-time surveillance in public spaces. Another area of concern is the lack of regulation and data security surrounding all the data collected with our facial recognition being put into place. Certain regions, like several countries in the EU, Canada, and even California, have introduced laws to combat the misuse and unethical implementations of facial recognition. This, however, can only do so much because as of 2025, there is no official universal standard that governs how facial recognition should be utilized. The EU AI Act is the most recent attempt to regulate facial recognition and classified it as high risk, requiring there to be full transparency and consent in order to use it. However, as for the US, the Facial Recognition Act of 2025 has yet to be passed, leaving federal agencies without clear guidelines on how to use or regulate facial recognition. Lastly, there has been some pushback on its credibility, as there has also been instances where facial recognition has shown to be biased or discriminatory. A recent case brought this concern to light when an African American man named Robert Williams was wrongfully arrested due to the false facial recognition match This case is currently used to argue that facial recognition is still far too unreliable to be used for lawful decisions. In terms of the future of facial recognition, there is a large range of opportunities it could be utilized in. The issue with the future is currently that the facial recognition is in a gray area and undergoing rules and regulations being made for it so it can be put in place within organizations and public spaces. Some people believe it should be publicly used, while others believe it is too powerful and should not be applied to the public no matter what. The reality of this is that it won't progress until more regulations surrounding the technology have been put into place, but by now many people have already been exposed to it or at least know about the potential of facial recognition, whether that be through our phones, law enforcement, identification verification, and much more. And this has just caused many to begin brainstorming on the big next way it could be utilized. Some of these ideas include enhanced accuracy and reliability in technology. This includes refining the technology to eliminate any reason for others not to trust it until it is deemed sufficient enough for public use. AI powered identity verification is another big one that is currently in talks, and likewise, as we have now, it would work similarly as AI, which is exponentially growing right now. These two paired together could see the creation of a new system being made where AI generates a database for facial recognition to sift through to match identities. The third biggest concept currently right now would be industry specific integration. Here we would see facial recognition being tweaked and tailored to each job and field as it is implemented into. Some of these are healthcare, which in which case it would be used for patient identification, access control, and emotion tracking with mental health. It can also be put into retail, which enables personalized shopping experiences and targeted advertising. And in the sense of finance, it strengthens security and prevents identity fraud. And we also have transportation, which would help make a seamless travel between normal airports and train stations. So that, as of right now, is as far as facial recognition has gone and its current process within the US government as well as worldwide. Thank you for hearing that detailed timeline and also just what's going on with it right now. I do have a couple of discussion questions that I wanted to bring up and just see if I can maybe spark a couple of conversations surrounding these topics. First, I would want to ask, should people be allowed to opt out of facial recognition when they are out in public? Why or why not? Also, I wanted to ask, do you feel facial recognition is moving in the right direction, or do you feel there needs to be things done differently in order for it to progress its development? And lastly, at what point or level would you deem facial recognition to be safe for public implementation everywhere? What if someone tried implementing within the US right now, like if it went through and it is being legally used by every entity, how would you react? And that is the rest of my presentation. Thank you so much, and I'm looking forward to having a conversation with all of you. Have a good one.